2019, which is based on the theme of automotive sector. I request Dr. Sunil to moderate this panel. Now, let me invite our representatives, Dr. Sushil Ramdasi from ARAI, Mr. Arun Kumar from GM, Mr. Mehak Modi from Ather Energy, Ms. Kathy D'Souza from Mobility Engineering Consortium, and Mr. Sachin from Fiat Chrysler Automobiles.
Guys, so looks like I have to make an assumption from the morning session and the afternoon session that the automotive sector is less interesting compared to aerospace engineering. No, that's what you guys say, but the people who are outside are saying the other way around. Yeah, that was just to kick it off with teaser so that you all are awake and participate fully. So I know we have a dais full of experts, and I wish I could say the same thing to the audience, saying room full of audience, but couple of empty benches, so we should be able to cater. And I actually have 2 pages full of questions, which is great thing to start up. So I think we will have enough to talk about. I think we have it's 2:50 now. What time are we closing? 4:15. Okay, so 4:15 is when we are closing. So that's about 1 hour, 20 minutes is what we have. So without much ado, we'll get started. So what I request, so welcome all the panelists. As you can see, and you have also witnessed various industries they represent, from. I think we have General Motors, ARAI, Mobility Engineering, then we have Energy, as well as Sachin in Fiat and Chrysler, basically automobile companies. So we have representation from across the automotive sectors, and I am the odd man out because I belong to none, and I actually belong to everybody because I actually represent Tata Group level. Then we have a program called as Open Innovation, which you heard in the morning, called as Tata Innovers. And we do work on automotive problems, which mainly come from Tata Motors. And Tata Motors vertical called as Pro Life, right? And I'm here in Dharwad as well to talk to the Tata Motors Dharwad, to see if there are challenges and problems that they want to solve for themselves. So which could be very good for students like you. So I would not repeat myself because I've already introduced myself and I've also talked about where I come from, etc. So for those, are there anybody who did not attend in the morning session? Morning session? Okay. You can probably talk to your neighbor and he'll tell you what I am. So, sons and services, and I run the program called as Tata Innovers, which is the Open Innovation Program. Mainly to cater to the technical challenges of the companies, and these challenges are open to the world, and you also can solve these challenges by logging in and submitting the solution, and we will evaluate and get back to you. What is in it for you? There's a lot of cash award, right? We have cash award ranging from 3 lakhs to 20 lakhs, and sometimes we go with the solver and say that yes, we can also fund you 90 lakhs. 90 lakhs worth of projects also have been funded. So it all depends on how valuable your solutions are, right? So I would now request, one by one panelists to actually talk about what companies you represent, and very briefly talk about, your career highlights, so that people out here also appreciate your background, and they also can make you perhaps one of the role models, if not all. Thank you. Yeah, you can probably take the mic over there.
I'm Arun, representing General Motors Technical Center in India, at Bangalore. I started as a diploma in mechanical engineer in the year 95. I joined Larsen & Toubro Limited as a service engineer, taking care of construction equipment service, repair and maintenance. So there is no difference between a mechanic and a service engineer. You have to work. So it's a construction industry and equipment has to work 24/7. It was pretty tough field. Don't choose construction industry. Okay. So I was there for 8 years, and then the industry was taking out all the energy. So I had to during that time I did my AMI, so which is equivalent to BTech. This is an institution of engineers in Calcutta which provides this equivalent degree, and of course this is recognized by IITs also. So by that degree and that experience, I could able to get in ISRO, Indian Space. So the ISRO is very good, and of course there is it's a government organization, so people prefer to relax, which probably make me to again not settle down. So I could able to join GATE and join IIT in the year 2006. This is after a gap of 11 years. So 2006 to 2008 it is from MTech IIT Bombay. Professor Seshu is my project mentor, and he offered me 2 projects. One is from General Motors Science Lab, and I got paid for those projects. Other one is from I think some belt, there's a seat belt designing thing. For both the projects, I got paid through Seshu sir, and even I traveled by air. This was my first air travel to Bangalore. And the project, of course, report and everything was meticulously reviewed by the GM Science Lab and the Professor Seshu. And of course, I got into GM in the year 2008. 2008 to 2012, I was into a process automation. I wrote a front-end GUI for one of their it's what they call lubrications. It's a lubrication analysis tool. It is in-house to the GM. So I wrote the front end. I have used C++ and OpenGL. And of course, the too much C++ and coding was little bit boring for me. So I could not choose because the team wanted to continue in the domain only. So then I had to switch it to Renault Nissan in Chennai, where I was given opportunity to lead a team of 12 members. And again, the domain is passive safety. So it is fantastic. Like it's an actual vehicle crash data you will get, and you have to process and simulate whether the crash pulses are clean and it is going to meet the regulatory requirements or the NCAP requirements. Those who don't know regulatory and NCAP requirements, every vehicle has to meet the crash performance requirements. And due to some concern, again I rejoined because some personal issues. So GM right now I'm taking care of lithium-ion battery pack development and predominantly to CAE. And GM provides a lot of freedom and design thinking, and it gives a lot of opportunity to think and contribute. So I should the company GM is very good, and yeah, this is all about my brief summary. Any questions? I'll pass.
Brief you about my organization. I'm Deputy Director from Automotive Research Association of India, that is ARAI. For last 25 years I am with this organization. That means after my graduation only. I started my career in ARAI in 6th April 1994. That means yesterday. Okay? Day before yesterday, only 25 years complete. I started as a trainee engineer, and in the process over the years I have gradually rose to this position of Deputy Director. I am leading one vertical that is called as Engine and Transmission Design and Development Center. Okay. So I have explained in brief overall ARAI activities and my departmental activities. Now coming back to my own career path in brief, not to take much of time. I completed my bachelor's in automobile engineering then masters in mechanical engineering, and finally I did my doctorate in electrical engineering. Okay. And right now I am a postdoctorate research collaborator with University of Delaware, USA, and this postdoctorate is in fuel cell technology. So this is how the academic career path. And in between, I did my masters in management systems, okay, MMS, in management information systems. That means how to design a complete softwares or a software product development cycle. Okay. So coming on a technical group, this is academic and technical. I started as a research engineer in powertrain engineering. That time it was called as a engine development lab. Now the name is being changed to the powertrain because transmission is also coupled with it. So when engine and transmission couples, it is a powertrain. So I started with as a test. Basically, to start work, started my first project was rather it's development of engine, or development of or conversion of existing three-wheeler into a methanol operated vehicle. It is in way back. That is 1994. The project was sponsored by the consortium of methanol manufacturers like RCF, Gujarat Fertilizers. RCF means Rashtriya Fertilizers, Rashtriya Chemical Fertilizers, Deepak Fertilizers. That was my first project. It was almost 3 years project. We converted one complete three-wheeler into 85% of the methanol and 15% of the gasoline. Okay. So that project was actually has given it has laid a strong foundation about the engine performance and engine characteristics, etc. I got exposed to all testing procedures, all experimental work. First 3 years, I was on a shop floor, and that is the biggest advantage I am getting today. Okay, I worked on shop floor from day one for almost for next 8 years. 3 years only on this project. Followed by then, after that, I started working on engines which are running with CNG, LPG. Okay, we did a lot of sponsored work for a lot of genset industry. There is one company in Hyderabad that time, I don't know whether it is there or not, Sri Shakti LPG. We converted existing kerosene 19 kW genset. Okay, you know that is from Honda CR to LPG operated genset. While execution of this project, I got an opportunity to write 2 patents. One is on the gas air mixer for constant stationary application engine, and one is for a pressure regulator which is used in CNG and LPG. Because the pressure is stored at 200 bar and each you have to mix it at 2 bar. Okay. Then after that, I started working in the field of design of engines, diesel engines and gasoline engines, and then finally I focused, or what I can say, converged on design and development of diesel engines. For the last 20 years, I'm in this area. So we designed and developed engines from concept till production. This also I explained in detail in the morning. Okay. Started with genset engines, then marine application engines, tank application engines, then automotive engines, passenger car engines. So almost all spectrum were covered. Almost all majority OEMs from like Mahindra, Tata, then Ashok Leyland, just name it. Okay. We have contribution in their entire product development, whether it will be engine or in the transmission. Okay. Now, for last 5 years, I think the buzzword is the electrification. Okay. So to align our organization's roadmap, we started working in the field of electrification, and then we took a very ambitious project, that is our own project, that is converting existing small commercial vehicle into a full parallel hybrid electric vehicle. Okay, and the target was that to achieve 25 to 30% fuel economy, fossil fuel economy. Okay, that means from point A to point B, if you are traveling in a diesel version, and if you drive with hybrid electric version, you will get benefit in the range of 25 to 30%. I think it's a big figure. It's a huge figure. Toyota Prius is the iconic vehicle in this segment, hybrid electric vehicle, which claims around 35%, real claim. Okay? And we want to demonstrate this fuel economy target on the road, not any standard driving cycle like New European driving cycle or US FTP highway. Okay? So we did complete, what I can say, the supervisory controller development. That means in which mode the vehicle will operate in engine zone, which mode it will operate in the electric mode or combined mode, like that. In which mode the engine will charge the battery through generator mode, etc. etc. It is called as the indigenous development of a supervisory controller. We tested it and we got almost 27% fuel economy on the chassis dynamometer. Chassis dynamometer, I think you are aware that instead of a vehicle running on the road, we have a dynamometer, okay, and vehicle is stationary, and chassis dyno is simulating your road conditions. Okay. Then one part of that project was to develop a full automatic manual transmission. It's called as AMT. Okay, you people must have known the Maruti Celerio, which is the first, it is called as the AMT version. Then followed by a lot of AMT versions by Tata and Mahindra. Okay, so right now in the world there are mainly three players. One is Magneti Marelli, then second one is Eaton, and third one is the Watco. They are having the products, that means they have the kits. Okay, like Magneti Marelli is having electro-hydraulic kit. Okay, then Watco is having pneumatic kit, and Eaton is having electromechanical kit. So what we developed, instead of 5-speed manual transmission, we devised 7-speed transmission, and that will convert it into AMT operation. That means its gear shifting, X, Y, and clutch actuation is done by electromechanical actuators. So complete software development and controller development, it has gone in ARI. Full indigenous effort. And while doing that, okay, the most important thing which I would like to highlight, we took 2 students from IIT Kharagpur. Okay, they are from electronics background. Okay, and in the process, they developed completely a microcontroller hardware. They are at the student level, master's level, from concept. What it involves, microcontroller means not to get the ready-made microcontroller like Infineon or Motorola, etc. But making a complete PCB layout, making Gerber files out of it, making a complete PCB hardware kit, manufactured it, and then complete assemble bill of material including resistors, capacitors, and different kind of chips, ADC, DAC. Okay. And there are different type of communication protocols like I2C, then JTAG, okay, then CAN. Okay. So everything, all those things, these things have been handled by 2 MTech students. Of course, they are the topper, okay, supported by ARI engineers. But this is what the success story, and that hardware is ready now, and we are going to test it. And the last, which I would like to tell this, that we are also in the process of making a fuel cell electric hybrid vehicle, okay, which is a PEM based as well as the SOFC based. So wide range of spectrum or wide range of engineering, what I can say, the different streams under one umbrella we are working on it. So it's not only one engineering discipline, mechanical engineering, but it's a blend of mechanical, electrical, power electronics, okay, and then microcontroller means computer engineering. Okay. So this is what the message I wanted to give it, that throughout for last 25 years, I'm not only working as a mechanical engineer, started as a mechanical engineer, but right now working in these 5 to 6 different areas. Reason is that my work profile, job demands for it. Okay. Thank you very much.
And if you missed this morning's session, I am a director at the Mobility Engineering Consortium, and we build platforms where students can build hands-on experience on projects. Since we are talking about careers, how many of you know what you want to do after you graduate? That's how many I was expecting, or even less. Yes, about 9 years ago, I was sitting in a similar room, not at IIT, but at the University of Toronto, and trying to figure out where I was going to go in life. I was in my 4th year of engineering. At that time, I wasn't just interested in school, I was interested in every extracurricular activity that was out there. I built costumes for the theatre, I was on the Formula team as team captain and as engine lead as well. I started the first dance club in engineering. I know it sounds really lame, but they had everything else. I just wanted to start an engineering dance club. I was a part of the Engineers Without Borders. So I was doing so many things at that time, and at the same time I didn't know what I wanted to do after I graduated. You must be thinking then why I went into engineering. Nobody forced me. In fact, it was my choice to go into mechanical, and I really loved the subject. Till today, anything with regards to engineering, in terms, even in bioengineering, I sit there and like just absorb everything like a sponge. That's how interested I was in the subject. I did an internship for 1 year during the course of my studies, and then I realized engineering was not my thing. So I am probably the least qualified in this entire panel. I did a bachelor's, and I wanted to pursue bioengineering in my final year. I was 2 credits short of getting a minor in bioengineering, and then I decided that my formula karting was more important. So I switched my credits so I could make sure I pass, and then ensure I have a car that was ready to go for competition as well. So my career path has not been a straight path. As I mentioned, after graduating, I had no idea what I wanted to do. And at that time on TV, there used to be this, I knew I was good at events, managing people, managing events, the details. I just didn't know how to get involved in that industry. So I thought, why not go into the wedding industry? And so I started planning weddings for people. But then you all know how Indian parents are like, right? Like, they tell you 5 years you spent, in your education, and here you want to become a wedding planner. Why don't you work in engineering? So the next 3 years I did work as in various capacities in engineering, just to make sure that this was just not a flight risk thing, that I'm suddenly scared and I don't want to do it anymore. So the first year I worked with Hitachi Truck Manufacturing. They build these big mining trucks where the tire size around 5 times your height. It is pretty amazing. I worked in as a standard designer, because they had switched through so many standards that the company, every engineer was using a different set of standards to design components on their CAD modeling. So my job was to streamline that. From there, I received an opportunity to work with Pepsi. So from heavy manufacturing to food and beverage. I was in Pepsi for 1 year as a quality control and then as a maintenance supervisor. So I worked the shop floor. I got to work with the people. There's this dynamic that you will learn when you get into the industry, and especially if you work in a unionized environment and you are not a part of the union. If you pick a bucket and walk around just because nobody else is there to pick it up for you, you will have a grievance filed against you, and then you will have to sit through why you picked the bucket up. So these are certain things that you will see in industry that you would not know right now. The difference between a unionized, I'm not saying there are many benefits with a unionized environment, it's the dynamic that you will get into. So that was 1 year of that experience. It was pretty amazing. But at the same time, I believe that we are in the 21st century, and in that mindset that the company that you work for, you want to feel that you believe in the product and you believe in the service. Before working at Pepsi, I did not drink Pepsi. I did not drink carbonated beverages. It was not my thing. So therefore, I realized that through the entire process, I was learning, gaining experience, but I was not believing in the product. And in the environment that I was in, everyone believed in the product. They were all, we bleed blue. And I could never look at that and say, I bleed blue, because I don't. Right, so from Pepsi, I went on, I had just started Formula Nord. For those who don't know about Formula SAE, or I started the first Canadian competition in Canada. That was my part-time, non-paying job after my full-time job. I got invited by the German competition to come and see how they are run. I went there. I quit Pepsi because I realized I could not work in that environment anymore. And no offense, the culture was great, but it just did not suit me at the time. And again, we live in a generation where unlike our parents where they really stuck at what they worked at for a long time. I don't know if that is a pro or a con. It's just as you go along with life. From Pepsi, I went on to, I was unemployed for 8 months because, as I mentioned, I was really into events. But because I didn't have a degree in event management, no company would hire me, even though I had all this extracurricular experience in it. So finally, after 8 months of trying really hard and realizing that my paycheck would be half of what I made as an engineer, I got an offer from a sponsor at one of my events who told me to join his company. They build testing machines for rotating components in your vehicles like pumps, oil pumps, cooler pumps, everything. And I took on that for a year. And after that, my career again took another curve where I had to move to India. I decided to get married to a certain, like my husband now. And one of his clauses, not clauses, one of our understandings was that I would move to India because this is where he's established, and I had no problem because I was still going through life trying to figure out where I wanted to be and what I wanted to do. And when I came here, I worked at Roche Pharmaceuticals as a communications intern. So as you can see, I have been going through different elements, and therefore there is this vast variety of knowledge that I've come up with, which is good, bad, because I haven't had much time to spend in each industry, but I've got an insight into each industry. Finally, 2016, this has probably been the longest job I've held till today, is a mobility engineering consortium. It comes with an understanding that wherever I've worked in, I've realized that I prefer to work for myself. And that is where I am at today, is that I am working for myself. It depends from individual to individual. I realized that a core part of me when I worked with different companies was I have an aversion to authority, and that aversion has sort of morphed into me running or working into building this platform, something that I truly believe in. And today I am here confidently speaking that this is something I believe in. I was a student. I believe in the power of practical hands-on experience. That's the reason why I joined the Formula team, because I wanted to build something from scratch. That's the reason why I joined engineering to begin with. And I believe there's a gap that my company is trying to fulfill or fill and connect people with the industry. So here I am. And what I wanted to tell you is that tomorrow when you graduate, it is okay to not know where you're going to be, next year or the year after. You keep figuring it out for yourself till you reach that soft spot where you're like, I really like where I'm at. And then you build yourself. As Sir mentioned before, you cannot be it's better to be the master of a trade instead of jack of all trades. So you can focus all your energy, your time, your efforts into growing something to become much bigger than what it is at the time that you joined. Thank you.
Very diverse set of activities that she has gotten into. Unlike Arun Kumar, of course he changed his jobs, and unlike Sushil, who actually stuck to one company, and he's still doing variety of things, right? And that's the beauty. And probably you can also look at variety as essence of your life, and that's where all of us actually are looking into. So there's one question out to all of you, and you can actually think over it and answer at the end. So what is that one common thing which actually Kathy went through all through her career, other than herself? So if you have an answer, you have a prize. All right, now over to Mehak. Mehak, please.
Well into how I got to career-wise where I am right now. The most important data point I have to give you is that in my first year, in my second year, and in my third year, I had no idea what I wanted to do. I also had no idea I would end up where I am. And more interestingly, in my first year and my second year and my third year, I thought I wanted to do three different things. And it really has always been a function of time. In my first year, I thought I wanted to just code. I wouldn't even go to mechanical classes. Like that is for grease monkeys. In my second year, somebody started building a car, and I'm like, wait, mechanical engineering school again. Went and got involved there, and found it really interesting, but never took it seriously. Like, oh, you can't really build cars, right? Like this is a fun project. Like to build cars, you need 35 years of experience in the automotive industry, for vehicles for that matter. So. In my third year, I thought that I will do, fancy masters in Stanford and get big paying job. I will do the Wolf of Wall Street thing. I spent some time designing websites for the cultural fest at IIT Bombay and things like that. In my fourth year, I'm like, that car thing was a lot of fun again. Let me go back and. See what we can do better, right? We did, so we said, okay, but we need to do more. So instead of one, we built 2 cars, right? One for the power event, one for the popular student event. Starting there, I thought, okay, now I want to join an automotive company, right? That is what I want to do in my fourth year. I want to join an automotive company, let's say, who comes for placements? Oh, Mercedes is here, maybe Mercedes. Oh wait, Mercedes day 20. Maybe there is Eaton on day 4, maybe I need to go to Eaton. The clear line of thought was that I still don't know what I want to do, but I had an inkling, and I always was what retrospectively I think worked out for me at that time was I'm never afraid to switch. Right, I'm doing web design, then I'm doing some machine learning stuff, and then I'm building car, and then I'm building some other electronics related side projects. By the time I got to 5th year, I was convinced I wanted to do a PhD. Okay. I got heavily deeply into chassis design. Figured out materials was really something that interests me, how materials work, etc., etc. I started applying to do a PhD everywhere, right? Again, I was pretty convinced I would do that. I got through job placements at Eaton, got through a PhD. By then, I changed my mind again because there was. I was spending a lot of time while working on a master's thesis on simulation software. And there was a job opening in a simulation software company, which is Altair in Bangalore. I ended up taking the job. It came completely out of the blue. I met somebody at a popular student competition incidentally who I was talking to what I was doing, and they were like, hey, we have an opening, it is in Bangalore. I took that up, and now I wanted to become like a math/simulation solver expert. That was the next 2-3 years of my life, which was really interesting. Right, I was building cutting-edge solvers while fixing Fortran code from the 1980s, for some of our customers. Right, again went back to coding. There was still an automotive element to it, and most importantly, enjoying what I was doing. Right, it was really interesting. And that was my focus until the thing happened again when I went to IIT Madras for some reason, and they met a couple of guys who were like, hey, we're building scooter. We're building an electric scooter. And this was 2 people, okay? They had, when they said they were building scooter, they had like really a bicycle with, very small battery. And they said we're going to make this into a company, right? My reaction was, you need 35 years experience to build scooter. These guys are crazy. They're going to lose all their money, and we are going to it's a waste of time. I let that thought go and spent another year with Altair until I heard about these guys again, and this time they had 5 employees. Like they convinced 3 other people. Which means there is something going on here. I spoke to them, still was extremely unsure. Mixed advice from all my friends and family saying, hey, okay, you know what, 10 people company, design scooter does not sound like a great idea. You have a stable job, potentially going to the US, but it was really tempting at that point in time, saying, hey, somebody's trying to build a vehicle, remember year 4, you really want to build a vehicle. Took the plunge, this was 4 years ago, and I've been at the company since, right? I spoke about Ather earlier today. But the theme continued. Even at Ather, I joined as somebody who was going to design the chassis. I designed the chassis in my first year. Then things again changed, right? I'm like, hey, this is not the most important thing for Ather at that point of time. We had a chassis, we were going, but we still hadn't defined the product, right? We can design a chassis, we can design batteries, we can design motors, but we should be able to sell it. So move to a product team there, trying to define what sells to customer, which is a complete change, right? What I've learned in the last 3 years in engineering is very easy because you can apply Newton's laws and get to the end of the answer. When you have to figure out why a customer would buy a product, unfortunately Einstein couldn't figure that one out, and it is a much harder problem. So with that technical backing, I was in a unique position to understand what is technically possible and what the customers want and go to a convergence of that. And the last 2 years I spent doing something completely different just because I enjoy it, to managing operations side at Ather. From a helicopter view, right? There's an operations team. However, I was involved in just understanding the finances, understanding the supply chain. Something again I not only thought I would never do, I thought that this is not a thing for me. I would never do this ever in my life, right? Because I want to engineer and PhD. So that's how I ended up at current role today. My role still continues to remain undefined, which is why I walked up to HR saying, please call my role something. And they said, how does chief of sound sound? I said, perfect, it's big and sounds important. That is how I got to where I am. And I still don't know what I will be for 5 years from now. And what I've learned to do is it's perfectly okay to be that, right? It is. I don't. I like, as people have mentioned, I am not a master at anything, right? Like I have, and most important thing to me, and this may not work for everybody, is that I'm not nervous about it. There is always something to do. There's always problems to solve across industries, across companies, across around the world. As long as you make yourself useful, I think it is you will find a way, and you will find a way which is interesting to you. Yeah, that's about it.
And things automatically falling into place because he was actually subconsciously looking at what is going to excite him. Perhaps that's why you kept on looking for things and kept on actually finding things which were more interesting and exciting in his life. So as he says, not all of us can fit into that bill, but you have to find your own sweet spot, and you have to find your own way of if I can use the word wobble around to fit into where you belong to. I think that's exactly what all of us should look at, because each of us are unique, and that's what I tell everybody. So thank you for sharing that exciting journey. So over to Sachin.
Yeah, actually I believe career, but still I will give some glimpse in 5 minutes. See, actually when we joined mechanical engineering, and we were 13 students from 12th class out, 13 friends from the same class who joined mechanical, because that was the hot subject at time. And when we passed out in 97, suddenly the picture was changing, like people were interested in computers, because our time it was only mechanical and civil engineering, and people used to go to other branches like electrical, electronics. Even though I was getting in one of the good college for computer sciences, I was not taking that, because parents were also thinking everywhere there is a mechanical industry. No companies like TCS and Infosys that time. But see, once I passed out of 13, 11 of my friends, they shift their career from mechanical to software. They did some courses in CDAC and all, and now also they are in companies like all these established software companies, most of them work outside India, then they came back here. So they have a typical career like software engineer. But we, two of our friends, we never like those kind of coding and that C plus languages and reading those books. And there are many classes in Pune, Kanekar, you go and read 6 months course and you will get job like starting like 25,000 immediately. In those days 25,000 was like 1 lakh today, okay. So, and our parents were also forcing us, why don't you follow this path? Why you were mad about automobiles. So we told them, no, we don't want this. We don't like at all, okay. Because in 4th year we did all these languages and all, which was a subject for this one. But see, then compared to my all other friends, software engineers, we were lagging in first 5 years. Because they were like, they have exposure to multinational companies and all. And we just joined the suppliers. Because that time for mechanical engineers, placements were very less. Companies are like, you will get only Tata and Mahindra. No MNC companies in India. And there are few companies like the suppliers like Bharat Forge, SKF and all in Pune. So if you are getting placed through campus, then it's okay. Otherwise you have to work with tier 3 supplier, which is at like you have to work for 12 hours at production shop. So like that we did for 2-3 years. And that time there was a spark that there was a dream like you should work with companies like Mahindra or Tata. But whenever I used to visit Mahindra in those days, what was the spark in my mind that I want to become a designer? Because that time whatever designer used to release the drawing, they used to sign on the hard copy of the drawing, which is not the case today. They used to sign on the blueprint. And we were so much respecting those designers, how they reached at this stage. So I interacted with some of my friends and they told that you really need to do post-graduation. So giving GATE and all. So all those things we did, and after GATE I joined particularly in OEM. So that is automotive industry in Mahindra. So I work first in tractor industry for 3-4 years in engine design and development. Then I went to Eicher Motors, which is commercial vehicles. There also I was part of engine design. So I worked on different softwares like ProE, then Ideas, Unigraphics. And that was a limited area, like we have to work with engine design, our manager. And we were part of some of the engine system. Not overall engine, but suppose like I was handling the crank train overall. So like that, those were some around 5 years I spent in 2 companies. And then I joined General Motors in Bangalore, which was a technical center open. And that was again also a lot of fear in mind that how we can survive in the MNC companies. Because those days there were no MNC companies. And we used to feel that the jobs are not secure. Okay, job in Tata Motors or Mahindra is most secure. Okay. But we took a risk and we joined the center because some of our friends were there. And in GM, actually my boss was from program management and he pulled me out from all this engine design and he told, okay, you work for a project manager for a particular project. And from those days, I used to know that how the projects is getting, means how the feasibility is getting done, then benchmarking with various vehicles, and then coming with the final product, and then execution of that project to deliver the complete vehicle. So I was part of Powertrain, I am part of Powertrain only right now. There are always 2 major departments in any OEM, one is Powertrain, other is vehicle. So I am part of Powertrain, but I am knowing the things from start of the business case sanction to end of the project. So like that, after GM, now I am in Fiat Chrysler, which is another technical center in Pune. And here I am working as a platform manager, you can say that as a project manager. And I was a part of this Jeep Compass project from powertrain side to localize the Fiat Veyron 2-liter engine, and we delivered it within a timeline, and we have a fantastic product on road. So this is my career summary.
You have to answer and name the person as well. So I'm just kidding. So I guess all of them were tensed actually, especially the front bench. They were almost going to move out of the room. So are in alignment with what he just said. By the way, all of them are mechanical engineers, right? Third year.
A person near him, Mike Modi, is also an IIT and he is in the mechanical engineering.
Correct. Yeah, that's good. So that should be a lot of experience. So there are examples of reverse brain drain, and I'm sure you would actually be also examples for those. I mean, assuming that we are all brainy guys, isn't it? So I think we should get into the core of what we are here for. The purpose of introducing the panel was to make you understand the nuances and the challenges and the ups and downs they have been through, and here they are talking to you about their career, so they can be role models for you when you actually step out into the outside world. Automotive engineering or automotive industry as such is very exciting. I was speaking to one of my colleagues, past friend from GE, and he is now associate professor in IIT Hyderabad. And it seems one of the common questions which parents ask when they come with their children. I'm sure in the first year, most of your parents came to the campus, very proudly stepping into IIT campus, and asking around, how is mechanical engineering? Is it good? Is it bad? Should I actually make my son join some other branch? And I think my friend had a very interesting answer. He says, as long as you have rotational parts, mechanical engineering is going to be there. So I think that is true, and in fact that is going to continue forever. So wheel is something which you will witness, and the wheel will always rotate and you will be evergreen. So automobile engineering, I think in the era of technology and in the era of advancements, I think has seen several facets, right? Be it if you go back in time to Ford Motor Company, Henry Ford actually started making the vehicle, and you can actually imagine the vehicle out there was which had big wheels and very small engine, and he was only making cars with the color black. And do you know why only in one color, black? Mass producing. So how is black related to mass production?
Because if you have different cars, it's difficult to paint each car in different color. That's the question that is asking.
I cannot buy into that, sorry. Anyone else? So he was making only black cars. And Americans call the boot space as trunk. Do you know why? Ford actually put a trunk to carry things at the back of the vehicle. And gradually UK, when they manufactured the car, they started calling it as boot space. And don't ask me why it is called boot space, because I don't know the answer. Right? So, and there is several things to it. And of course, Ford introduced mass production. Ford introduced a modular manufacturing, and there used to be called as a city by name Detroit. I'm sure it exists today as well, but it is mostly deserted because people actually went out of the city very recently. Rather, Obama's time, I think it went it was filed for bankruptcy and stuff like that. But essentially, the lesson here is there always used to be a continuous evolution of vehicles, of automobile, and the latest is in front of you. The latest is electric vehicles. Right? So I would like to ask any one of the panel members, and I don't think we have anybody other than Sushil to answer that question, or even Arun to answer that question, is that what do you think is the future of electric vehicles?
Yeah, I think in the morning I have touched upon this. The major challenges of electric vehicles right now today is the cost of the battery, and the most important thing is the range anxiety, and third one is the availability of charging infrastructure. These three things are putting the major hurdle in the progress of the EVs. You know that electric vehicles were present 100 years back also. Okay? But right now, why we are thinking it's mainly purely from the CO2. Because nowadays, whatever vehicles are producing, they are making 120 plus grams per kilometer CO2. And now in Europe, the target is that by 2019, it should come down to 80 grams per kilometer, not 80, 99 grams per kilometer. So electrification is one way of doing it. But as your question is right, whether it is the only answer and it is the solution. Considering that Government of India kept a target of 100% electrification by 2010. Not only Government of India, you might be knowing that Norway, Sweden, okay, even UK, they kept this target. But slowly now there is a mindset change that 100% electrification is not possible. So the road to 100% electrification is through hybrids. Okay, hybrid means again there will be one engine and there will be one motor. So during operating driving cycles, whenever engine operates in the inferior zones, especially under the park load condition and at lower engine RPMs, means particularly in the city driving condition, your engine will not come into the picture and electric motor will come into the picture, vehicle will be in the EV mode. Okay, and whenever you are in the cruising mode, it will be in the pure engine mode, and above 75% of the load, engine will stop, and then remaining 25% will come from the electric motor. It is called as the hybrid mode. So because of this, your engine bad operating points will get eliminated by the electrification, and the fossil fuel in the range of 25 to 30% will get. So I think this is a very good figure. Just imagine that tomorrow if you all have good hybrids along with you, 25% fuel reduction is a huge saving. But problem is that then why not hybrids are too much on road? Cost. You know, cost of the Toyota Prius, it's almost touching to 35 lakhs to 40 lakhs. And the person who is going to buy the hybrid 35-40 lakhs car, at least in India, he is not going for a fuel economy. It's for a status symbol. So he will go for, I think, Mercedes or BMW. But why this is happening? Because there is no volume. Once the volume starts picking up, okay, cost of battery, cost of power electronics, motor will go on, and then those what is the delta difference, it will come in an affordable range. So my straight answer to your question is that EVs is the final answer, okay, but it will come after 2030 and 2035, maybe 40%, 30%, not 100%. It will be first HEVs, then EVs, then fuel cell hybrid electric vehicles, so that you will get more range because you have hydrogen on board to generate electricity and to charge the battery. So there is no worry of range as well as there is no worry of charging, availability of charging infrastructure. This is the roadmap.
Thanks, Sushil. Here and they are here to stay. How we adapt, how fast we adapt is the question of the time. It's a question of technology adaptation. Yes, please.
Question, sir. Actually, looking at other things. So while we see electrical vehicles, end of the day we are going to charge it with the electricity which is produced, and in India 80% of the electricity which is produced is through coal only. So emission of coal is quite higher than emission of natural gas is another thing. So basically, aren't we shifting the emission from individual vehicles to shifting the emission to somewhere in bulk, somewhere in electrical, where we are producing electricity power plants or somewhere? So is there any solution that?
Yeah, I think that's a very good question. In fact, shifting the blame game to the power manufacturers versus the car in itself. You might not be right, completely there. Because of the fact that there are also alternative energy which is being explored in the power generation industry as well.
That was my question,
right?
sir. What exactly are the
Alternative fuels, alternative energy sources. I'm sure Mahek, you've got an answer.
There are two major steps we need to do, right? Majority of the CO2, let's say a large percent of CO2 comes from power plants, the second half comes from vehicles, right? So there are two things we need to do. We need to move all our power plants to renewable energy. We need to move all our vehicles to a renewable technology, right? That's something that doesn't produce CO2, right? It could be It could be batteries, it could be fuel cells, but it cannot produce CO2. These two are not either or problems. You have to solve both, right? The method of solving both these problems is completely different. To replace all petrol vehicles or diesel vehicles today, fossil fuel vehicles, with sustainable ones, is a slow process because you have to go to individual users, right? Maybe commercial or private, and ask them to change, right? It is very hard for a government to set directive, okay, from tomorrow only electric vehicles, or from, it has to be a gradual change, right? Power, on the other hand, is typically something that is easier to do a sweeping change of for a large entity like a government of a country, right? For example, a lot of European countries took a call to move away from nuclear, and they could do it in a much shorter time span, right? Because it involves the company investing, it involves the country investing in some amount to change their power plants from a renewable source, a non-renewable source to a renewable source. These two independent plans are the fact of switching over vehicles is the harder one, right? Yes, you are right that you are moving the CO2 emissions to instead of distributed to a central place, but that is really step one of the plan to renewable energy, right? And it enables or makes easier step two, which is make sweeping changes and get rid of coal or gas power plants. It can be done in a more controlled. It can be done in a more controlled manner. Also, if there are centralized points of production, there is carbon capture technology, etc., that's coming up to address that individual problem, right? Instead of 50 companies having to fix their engines, it is one power plant company that has to fix their CO2 emissions. So it leads to an easier problem to solve.
Yeah, thanks, Matt. So,
pollution from one place to another. But the real thing, like one more addition to whatever Matt told, the efficiency that which the IC engines operate are hardly 30 to 35%, and the electric motors are much efficient. They operate at 85 to 95%. So this is one of the area, like you cut down IC engines and you increase the efficiency. Second thing is that these electric vehicles can in turn store energy and can give back the energy to the grid. Like nowadays there are rechargeable, like when you go down the hill, your batteries will get actually stored up because you try to capture the energy from the wheels and back charge the cells. So you increase the efficiency, that is one point. And always you try to operate the motors at their, like the motor curve, if you see the efficiency curve, it is more or less flat. So it doesn't drop down like the narrow range that IC engines have. And the alternative energies like which is booming up in India, like the solar cells, and which is predominantly good, and wind energy. You can store the energy, and the lithium ion is actually going to change the field. I think like automotive industry is going to see the change, because these lithium ion and fuel cells are more energy dense, and they can give high range. Even the cars can go up to 300-400 kilometers in a single shot of charge, which is more than sufficient for a week in a city dwellers. And then you charge it for 8 hours. At night you put out and it charges. It's not going to see the problem. I think to answer the other question of battery swapping. So yeah, thanks.
Yeah. So I think which is produced out of fossil fuels is in surplus and is actually going to be perpetual. It's absolutely nonsense. Right? No country can actually say that energy produced through fossil fuels is going to be perpetual. But there is also another side of the story, that in the entire European industry, region, if you actually go and ask them, power is actually surplus in European community today. And in fact, government is actually announcing aids to European consumers, that if you guarantee me these many units of usage in the next month, I am going to actually give you a subsidy. So energy actually is in surplus. Another fact which is aligned to this is, entire European region, a big manufacturing company of turbines could only sell one hydroelectric turbine. hydroelectric turbine, just one was sold in the entire year. And this I'm not talking about years ago, this is just 17, 18 sold. So energy is in surplus. And when you talk about making all the vehicles electric, the challenges are going to be there, are bound to be there. And that's where the research is going to happen, that's where innovation is going to happen, to identify alternate sources of energy, if not from coal. Right? It could be from wind, it could be from waves, it could be from solar. Fuel cells are probably going to be the answer for that, for a few vehicles, at least at the light commercial vehicles or even passenger vehicles, that you can have, the fuel cells on your vehicle in itself, and ensure that it's giving you the power to mobilize your motor car, right? So in fact, I am actually running out of time, and I would like to focus on a few questions, and again any of the panel members can take this up. Is that I'm a mechanical engineer, and you talk about I think all through today we have been talking about multidisciplinary approach to anything we study. So then why am I affiliated to mechanical engineering, and why am I called a mechanical engineer, etc. Right? So it is going to be the order of the day, guys, and you have to accept it. And the question from them is, if I am a mechanical engineer, and what are those skills or courses or expertise that I can pick up from other branches, is what they're asking. So anybody from the panel can answer that. Is the question clear?
Is it okay?
Yeah.
Just take 2 minutes, then I will pass it on.
Sure.
Very good question you have asked. Okay. First thing, as far as only your basic core branch, mechanical engineering. Okay. I will explain it now by taking an example. Let's take an example of hybrid electric vehicle. Let's take an example of Toyota Prius. It is the best example of having all engineering disciplines under one roof. Hybrid electric vehicles. Why? It is having on-board engine. Engine itself is having all your engineering subjects, almost 40 or 50 what you learn in your UG or post-graduation. Starting from thermodynamics, fluid mechanics, engineering mechanics, strength of materials, machine design, theory of machines, vibrations, everything, you just name it, and mathematics is at the base. So the first thing, okay, you should be thorough in your own all subjects. Okay, is it clear? Thorough means what? Your fundamentals should be very clear. It's not only that you have got the 90 marks or 95 marks, whatever it may be, but your real application of the D'Alembert's principle to design a connecting rod and the crankshaft, what loads and torques comes on it. Such kind of things should be very, very clear. Okay. Second one, as far as the multidisciplinary question comes, once engine is there and once you are through with it, the second power plant is the electrical engineering. Okay? So electrical engineering, so hybrid is having two power plants. One is the mechanical, one is the electrical. It starts with the battery, then DC-DC converter, then power electronics, that is the inverter, and then finally motor. And motor is driven by a motor control algorithms. So in this process, it's not only electrical drive. Okay, electrical drive means you should have electromagnetic induction and electromagnetism concepts. Faraday's laws of magnetic induction, Lenz's law. You should start with that. How the flux is created, how two flux interacts, and how these two fluxes creates a resultant torque or force. You got my point? Then Fleming's left-hand rule. All those things, basics, you should start learning. Okay? So then, electric motor, induction motor, PMSM motor, etc. Then, depending upon driver throttle position and the speed what he demands, how much exactly DC power need to be converted into a variable AC power. That is done by a motor controller such as direct torque or field orientation controller. You require a thorough understanding of basic electrical engineering, okay, such as voltage equations, current equations, flux equations, okay. Then you should be thorough with fast Fourier transformation, Laplace transformations, etc., etc. Okay. Then matrix algebra, vector algebra. So that is the core of electrical engineer. Even you are mechanical engineer, you are studying it in the mathematics, but the application is in electrical engineering. Then the third domain is the power electronics. Okay, it means inverters, 3-level inverters, 5-level inverters, which does the job of converting DC into a variable DC. So you should know what is thyristor, transistor, okay, what is BJT, what is MOSFETs. So all this basic knowledge you require. Then battery technology. When you go to the battery, that means again it is a chemistry. It might maybe lithium air, lithium ion, lead acid. Okay? And then finally the most on top, what it sits is a control. Control engineering. Okay? Control engineering means what? You want to decide in which modes engine should operate, in which modes motor should operate, and when both should operate. You got my point? And when state of the charge battery drops, then how BMS comes into the picture, it's shut off the motor and then engine starts and it charges the battery and motor is acting as a generator. So it is a development of a controller. So controller means development of all transfer functions. Okay? Then frequency response functions. Then you should know all these Nyquist plots, Bode plots, etc. etc. You might be studying it, but you should study it from the application point of view. So MATLAB Simulink is the tool. Okay, what I suggest, apart from your conventional mechanical engineering softwares like Nastran, ANSYS, CFD, that's fine that you are doing it. But one simulation tool like MATLAB Simulink, where you can develop and design control systems, is must if you want to work in future mobility options, advanced mobility options. Okay? And on top of that, I suggest at least you should know basic programming language thoroughly. And to me, it is C++. It is a system level language. It will never die. Okay? On commercial side, you have so many versions like Java, Python, okay, on database system, Oracle, so many things. But C++, Visual C++, now it has been shifted to .NET environment, C#.NET. You should really master in this because that becomes a platform to program in MATLAB Simulink the control systems. Okay? So you should be thorough in the mathematics, control system applications and one programming language, plus electronics and electrical. So it's a multidisciplinary. So somebody said that you should master of one, jack of all and master of one. But nowadays I will slightly modify it. Okay, jack of all, but not master of one, but at least master of two or three. There are people like that. Thank you.
So I would shift to the other topic so that we can get into more important and curious questions from the students. I think I just wanted to add to what Sushil just pointed out. All of you should actually look at one thing at the core. And that could be in the form of your course project, that could be in the form of what you want to learn. And I'm sure you have your fellow friends in other branches, right? Electrical, computer science, electronics, etc. Find the niche area and try to bring together there your friends and create something together. And today is the era of co-creation. I think you should actually find that one area, one core thing which you want to do. Could be manufacturing electric vehicle, for example, and bring your friends from across other departments and try to build one unit or one device or one vehicle on your own. And actually that will teach you most of the things, most of the nuances of what goes into an electric vehicle or any other topic. Maybe you want to build a drone. Fantastic. I mean, that has mechanical engineering in it, that has electrical engineering in it, that has communications engineering in it, because there is wireless you talk about, there is GSM module you talk about, etc. GPS, I'm sorry. So, plenty of multidisciplinary projects can be picked up, and I suggest you do that, and I'm sure you would actually learn most of these things. Otherwise, it's going to be fitting into trying to do something on your own and not leveraging the expertise around you is going to take longer, and you could resort to doing that, but I think you should look at leveraging what you have it around. I think one of the famous scientists said, educated man is stupid moment you take him out of the field he is educated in. Right, and this is not my statement. This is from same famous scientist actually said this. So that's it. You take yourself out of mechanical engineering, you look stupid. All of us look stupid. So you have to put yourself into that location, into that position, and try to co-create with a lot of other friends in the institute. And that's the order of the day for all of us here. Right? We don't actually build everything on our own. We actually look at the facilities which are available within the industry, within the company, to build something which is multidisciplinary in nature. The biggest advantage for you guys is that you have those things available right next to you, and along the course you are also learning. I think you should stick to that. With that, I move on to possibly the next question, which is bugging most of you, is that automation is going to take away a lot of jobs. Right? That is a concern, and this concern has been there for a long time. When Y2K happened, people thought a lot of IT companies will close down. When .com bubble busted, people thought the .com industry is gone, IT is gone, software engineers are going to go home and commit suicide. Are they today? They are still excelling, not just surviving. So anybody from the panel who want to talk about if automation is being picked up, in what areas automation will be, and if it is going to kill all the jobs in the market.
So, is automation going to kill all the jobs? Yes, probably eventually. No, that's a joke. My straight answer to be that shouldn't be a fear for you guys, that should be a fear for all of us here. Because our jobs are more likely to get automated. However, the real answer to the question is yes, there is more and more automation happening. This has happened even 200 years in the past, where everybody thought, oh, these mechanical machines are coming up, they're going to take away all the jobs. Imagine, I'm going to put it, 10 years ago there existed. Maybe 15 years ago, you would walk up to say, my job is to be a YouTuber. You would be laughed at and you'd be like, wait, what is YouTube? They're jobs that got created out of technology that just came out of nowhere, right? YouTube is like a 12-year-old company at this point. So, just entire new genre, like at least like 10 to 15,000 people who have this as a full-time career. There are things for people to do, right? Like there is already so much talk about a new generation of vehicles coming on, new forms of transportation. Yes, autonomous vehicles are a way to take away jobs, but they're an incredible way of creating jobs, right? You are sitting at the precipice of us saying we're going through the next big leap in the automotive industry, of essentially saying we're going to move to an autonomous car, and you are sitting on that, right? Today, you and me are at the same level, right? I know as much about autonomous cars as you do, because it's a completely new field, right? You guys have, to be honest, at this age, a more open mind, less fixed ideas. So, in fact, you all have an advantage at this point. As long as you're aware that there is more and more automation happening out there, it is something that we need to learn to embrace, and it is something that shouldn't worry about. The thumb rule that I tell people is that typically, eventually you are always working towards automating your own job, which is a good thing because you don't want to do your job all your life, right? So just treat that as a thumb rule. I think that's a reasonable thumb rule. But I don't think it's something like, it's not an end of the world scenario. It is just that new jobs that you cannot imagine today are going to exist 15 years from now. And you just don't know how they look like today. And maybe one of you will be doing that, okay? And you all don't know what you're going to be doing.
Thanks, Matt. One thing which is going to change the industry, automobile industry in future, which maybe it will come in the form of advancements in automobile sector. So one advancement we already spoke about, which is conversion of fossil fuel based engines into electric engines, and we talked about electric vehicles, we talked about the evolution out there, etc. What else could be the change? And I would like to pose this to maybe Kathy, because she is in the world of mobility engineering. So I just wanted to make it very specific. How does AR and VR and ER going to actually change the face of automobile engineering? And I would expand those acronyms: AR, augmented reality; VR, virtual reality; ER, extended reality, right? And in fact, one of the advancements I was actually looking at was from one of the famous car companies, which I forgot. They actually have created, just like flight simulation, they have actually created a model space for their customers to experience how the vehicle is going to behave. And customers and consumers are actually brought in. They are given this experience of their next models and capturing their feedback to improve the model. So any thoughts or any experience from your background?
So what I have been face to face with is more from an endpoint user, as in a customer to a company. In terms of virtual reality, which is becoming such a huge, it's really used when you go to trade shows, when you go to, when you meet with a company for the first time. They cannot take you to the factory, but what they have is an entire, what you'd say, a system based on virtual reality. You put on something and you've seen the entire factory, you've seen how the processes work without you having to go to the shop or to the factory where they are at. It is not only changing the way we look at the way we look at factory visits or anything of that sort. You reach the customer so much more faster by just doing this, by having them sitting in a random place, in a random, just wearing it, going through, seeing how your interactions are with people, what kind of workspace you have, what kind of environment you have. In terms of a customer, an end customer who's eventually going to invest in a company, isn't that pretty awesome that you don't have to travel, go there directly and have someone take you through a tour when you can get everything done within the first 5 minutes over there?
Yeah, I think that's going to be the future as well when you look at car industry or automobile industry. So few of the advancements, if you actually talk about in automobile industry, is going to be connected cars, right? I know we talk about this a lot in the aerospace industry, wherein craft to craft communication becomes extremely important, and even in aerospace industry the advancements are not so much, wherein my aircraft can actually communicate with the other aircraft so as to probably eliminate a possible collision, number one. So can I think of the same thing in connected cars? So here the connected cars is not in the context of talking to other cars, but it is really talking about how I can communicate from my car back to the model space which is sitting in the car, and that actually is called as digital twin. Moment I actually, have you heard of digital twin? Twins? All of us are aware, right? It's just a replica of what I am. So similarly, when the car is rolled out of the factory, you actually create a digital model of the car and make the car on the road communicate to the model in the whatever design space or company which you have, and essentially tell me what it is going through. Are the brake pads okay? Is the engine okay? Is the vibration in limits? Is the fuel economy okay? Is the efficiency okay? So bring it back to the model space and the desk or the workbench, so you can actually constantly communicate with your customer and tell him that, look, you are actually due for something. And that is the era which we are getting into, and that is exactly what we mean by Industrial Internet of Things, IoT. Sensors are now the next thing, and not only, sensors have always been there. Right? Sensors have always been there, right? It's not that we have invented temperature sensors, humidity sensors, or vibration sensors today, because they are all aligned to the common, basic principles of mechanical engineering. Right? If you talk about a vibration vibration sensor, what is it? Sorry? Accelerometer, but based on what? How do you sense acceleration? How? So what is that motion called? How do you sense that? Strain gauges, for example, right? So it all boils down to basic fundamentals, and now we are talking about connecting them, communicating, and that's where your connected cars come into picture, that's where your Internet of Things come into picture, and that's when sensors start communicating back to your model space, and thereby I actually see the map of actual performance of the vehicle on my digital model, so I know what to do with it. So that is going to be the next big thing, and if you have any questions now, we do have a couple of minutes to take a few questions, or maybe a couple of questions. Any questions from the audience while we are discussing this, And while I have exhausted the list of important questions that were actually marked and communicated to me. Anything else which you wanted to ask? Yeah.
So how will Hyperloop purchase the
Thank you very much. Elon Musk, who I would love to answer I would love him to answer that question, but unfortunately we can't get Elon Musk here. He created a company called the Boring Company. Do you know that? Yeah, the Boring. He called it as the Boring Company because he was only drilling holes to ensure, basically, to make the tunnel transportation, wherein you travel by car, you actually go down into the tunnel and you just close your eyes like you are in Disneyland. You are into your roller coaster ride and you are there at the destination. You are elevated back onto the road and then you go to your office. That's the tunnel based. Hyperloop, I think, was an experiment. Like Elon Musk keeps experimenting with SpaceX, like electric cars, like the Boring manufacturing company, etc. So it is. I have only seen YouTube videos in terms of Hyperloop. I don't know if anyone has any more information on Hyperloops.
I'm going to try and answer this question. What are Hyperloops going to do? Hyperloops are going to completely transform the way transportation works, right? That is what they're going to do. Do they exist? The answer is no. Somebody needs to go build them out. Can they exist? It has been proven that the answer is yes, right? This is how the next 5 to 10 years are going to pan out, right? We need people, we need companies, we need engineers to actually figure this one out, right? When again railroad started, we needed people to figure it out. It theoretically works. There have been enough companies, student competitions, etc. There are university teams that have built Hyperloop prototypes, right? So it's a question of implementing it, and I don't think that it is disputed that implementing a Hyperloop is game changing, right? It is the new trains, it is the new planes, it is a new way of making the world smaller.
All right.
So, FEM. He's written a book on this subject, but there are many other analysis methods, such as CFD, finite difference methods. These are what I would like to say are approximations. They're rather good approximations. Everyone says it's important to have hands-on experience, but in the industry, how important is FEM to the companies? Like, especially startups like Aether, who have very limited funds, they have to make prototypes. At the same time, they have to test it. So how important is FEM? And also my dad works in a company, Technic FMC. Conversing with him and a couple of people who came here for the workshop, they have told that there are very few people who work in the industry, FEM industry. And so, how big is this industry and what is the scope of that industry?
So, it's how important finite element methods is for industries. Ardhendu is around. I think, if I tell that it is not important, Ardhendu is going to kill me first, right? And then he would answer your question also. But let me tell you, finite element methods is very, very important for industries. Essentially to look at simulations, analysis and results of the analysis, and to make changes to the design so that the weakest links are strengthened, weakest links are actually eliminated. So be it in the car, be it in locomotives, be it in healthcare, be it whatever are the end user appliances you talk about, consumer and industrial. I think these are fairly well understood topics. And if you ask me that industry is not interested in knowing FEM, probably not. Maybe they have proven models and templates which they are today using. So if you actually prove it once, and barring everything else, in terms of material properties do not change, there is no variability to manufacturability, etc. The FEM model should fairly spit out the same result. Same deviation, same deflection, same dynamic behavior, etc. Now, you can actually now take that FEM to the next levels of how does FEM going to fare in a dynamic scenario, in a transient scenario. and there are multiple modes of behavior. And you talk about 3D manufacturing today, there is multimodal physics coming into picture. Now, have we applied FEM and FEA to multimodal dynamics, wherein I am talking about one material bonding with another material and so on and so forth. Because please understand, additive manufacturing is not just there to eliminate subtractive machining, it also is to impart great strength factor and performance factor into the components, because the functional part is going to be made much more stronger, so I have a stronger material there, and the non-functional parts can actually be made with not so high strength alloy. So I can actually look at changing as I build it. As I build, I can actually change the properties, material characteristics, and hence I, number one, spend less cost, and number two, I can actually have an adaptive behavior of the material. So it has got multiple. So are we ready with multimodal physics behavior? I cannot just blame it on one software which is in Abacus or ANSYS analysis software and say that here is the model and you go figure it out. No, I think there is engineering to it, there is mathematics to it, which we have to understand and implement. I don't know if
To answer your question, see, we have our technical center in Chennai and Pune, and out of 600 people, we have more than 500 in simulations. Because see, all automotive OEMs are first working on simulations so that they can project it, because we cannot make all the prototypes within a one go, and we can test it because it requires lakhs of kilometers testing. All these things can be simulated and projected by simulation. So we have a lot of departments like Crash, Dura, NVH, then Interior, CFD. So all these guys are working on simulations based on the expertise developed in our US R&Ds. So that is one of the hardcore, means you cannot neglect that.
I couldn't agree more if you want to make that as your career. In fact, I have friends who are working in Abacus company building these meshing software from the scratch. So all of us talked about CATIA, all of us talked about AutoCAD, etc. And there is mathematics behind all that, right? The nerves and the curves and the Beziers and the B-splines actually are mathematical curves. So if you don't know how to build a 3D curve or how actually it is built, you don't know how a 3D surface is built and how it is going to behave. So it's extremely important that all of us actually understand the mathematics behind it. Not for the heck of it, but really to understand and appreciate the technology which goes into it and the way material is going to behave. Right? And that is applicable to all areas, not just modeling or design space.
Never dying area, plus it is very much respected. It is not like a ready-made software available and you should do it. It is like you have to apply your brain there. Means see, in most of the simulation recruitment, most of the people are coming, at least they should be a PG or from IITs. Whatever GM is recruiting, or means whatever I am aware in GM also. And if you go in Tata Motors also, they will take MTech PG people in simulation.
Absolutely. It's end of the market is demanding it, or you will become obsolete if you don't know about it. Think of
Your passion actually.
yeah, it's your passion, right? You exist because you are passionate about something. It is not because you want to do it because I want to get my salary, right? What used to happen to the Fortune 500 companies 100 years ago, and what is happening to the Fortune 100 companies today? What did not exist 15, 16 years back exists today, and vice versa. What existed 15 years back does not exist today. I mean, we talk about Kodaks, we talk about Nokias. I mean, Nokia still exists. BlackBerry, research in motion, it's gone with the wind. So, I mean, once upon a time that used to be most coveted, mobile in my hands. I used to feel so proud because it gave me QWERTY keyboard to type my emails. So, everything is washed away with smartphones coming into picture. So you are not adapting, you are finished. And that is the way of life. And I think you should understand that the donkey years of companies is now dying faster, and it is actually becoming now, dog years. And it's going to reduce further. So you don't adapt, donkey years companies are going to vanish, and dog years are now here, so you have to upgrade yourselves to survive in the market. And companies are finding numerous ways to exist and survive and excel. And you go and talk to any of these, Fortune 500, Fortune 150 companies, you have those companies thinking about excelling not just today, but for 5 years and 10 years in the future, 25 years in the future. And they have roadmaps. General Electric, for example, bad example today because it is going through very bad patch in their entire history. But I'm sure they have plans up their sleeve to actually come back much stronger and excel for next 5, 10, 15 years. And go talk to any other company, Siemens, Philips, Enel, Tatas, all of them have plans up their sleeve, and if they don't, they are going to vanish. And now organizations, you bring it down to individuals, because individuals make up organizations. Individuals make up teams, teams make up functions, and functions make up organizations. And it boils down to every one of us. And we make, we are actually significant portions of that particular ecosystem, and we all have to be ready, prepared to adapt ourselves to get to that level, so we excel and organizations excel. And if we don't do it, please understand someone else is going to come and do it. So there is nobody in this world who is invincible. I am standing here, Tata doesn't think that I am invincible. Everybody is invincible, so please bear that in mind, and don't do things for the heck of it. Do it because you like it. Do it because you are passionate about it. And that is the key mantra to actually move yourself ahead. And not really looking at, automation is going to take away jobs. AI is there, what should I do? Machine learning is there, what should I do? I have FEM, I have CATIA. So, no, I think, another way of looking at things is break down your complex things into simpler, manageable things. And that's exactly what Six Sigma quality management teaches you. I'm sure Ardhendu will agree with me. Break down complex jobs into simpler tasks, so you make them manageable, and you think that it is manageable, and you can actually build things up from there. And you don't actually go onto the 11th floor or 12th floor in just one go. You go step by step. And I think you should look at it as that, and don't look at the entire building. Of course, it is important to understand the big picture as to where you are headed, but you have to take one step at a time. And with that, I think if my panel members have nothing else to add.
Just to answer the other specific question, the FEM is absolutely vital to us, and FEM saves us money and not costs us money.
Yeah. So I was actually looking for, not all that useful for the companies. We can have a chat. These are important questions, and you should ask. And asking questions is never ever treated badly, both in academia as well as industries. We encourage youngsters like you to ask questions and learn. It's better to be stupid now, not that you ask a stupid question, than stupid for your life. So thank you very much, guys, and thank my panel members a lot for sparing their time and also sharing with you some of their key highlights and also sharing with you their wonderful journey and the experiences that they have had in the past. So thank you very much, my dear colleagues, and thank you
all the panelists for us. Now I would request our organizers to provide a token of appreciation. Please give a round of applause. Yes, can we have some more? Keep it going.
At the occasion. On the behalf of IIT Dharwad, I would like to extend my hearty vote of thanks to all the panelists for devoting your time and efforts and sharing with us your findings and opinions today. Today was the session where we as a student were thoroughly motivated, and many of us who were confused what to do in life. I'm pretty sure all of them will now have a clearer vision for their future goals. As Mr. Dhodi said, be jack of all and master of one. And as Dr. Sushil pointed out, that you should be master of more than one. I think what they were trying to say is, as an engineer, we should, our main motive should be to have a solid foundation and build the surrounding knowledge around it. This shows that an engineer is not restricted by his field or branch. One should be capable of grabbing all the opportunities knocking his or her window, because the one who knows what he doesn't know is the one who knows what he knows. I hope Professor Prabhu won't mind me using that. And at last, but not the least, I would like to thank the DIAL team for working day and night to make this event a success. I thank our professors for guiding us and helping us anytime round the clock. This event wouldn't have been possible without the we part in the team. Again, thank all the panelists for sharing your time with us and enlightening us with your great ideas. Thank you.